13.8 billion years ago, everything that would ever exist burst into being from a point smaller than an atom. Or so we thought. The James Webb Space Telescope, humanity's most powerful eye on the cosmos, wasn't launched to shatter our understanding of reality. It was built to confirm the greatest story ever told about how everything began. Instead, it's revealing galaxies that formed too fast, black holes that grew too large, and structures that organized too quickly. We're about to journey through discoveries that suggest our origin story might be completely wrong. If you're ready to question everything you thought you knew about the universe, make sure to like and subscribe because the truth is stranger than fiction. $10 billion and 30 years of planning created the most sophisticated machine ever launched into space. The James Webb Space Telescope wasn't built to surprise us. Scientists expected to see tiny, primitive galaxies stumbling through their first steps of formation. Like opening what you expect to be a baby photo album and finding portraits of fully grown adults, the telescope showed us galaxies that shouldn't exist. These weren't the cosmic toddlers we expected to find in the universe's nursery. These were massive, organized, mature systems blazing with the light of billions of stars. Picture this. You're told a forest takes 100 years to grow. Then you discover trees that are fully mature after just 10 years. Galaxies that should have taken billions of years to form were already there, fully developed, just 600 million years after the Big Bang. Webb's infrared eyes can pierce through cosmic dust and distance like no telescope before it. Its mirror stretches 21 feet across, gathering light that has traveled longer than any photon humans have ever captured. This gives us a time machine that reveals the universe when it was barely 3% of its current age. The telescope's discoveries have created what scientists quietly call a crisis in cosmology. Research teams around the world are scrambling to explain observations that shouldn't be possible. The very foundation of how we understand the universe's beginning is cracking under the weight of evidence. Every image Webb transmits back to Earth forces us to confront an uncomfortable truth. The story we've told about cosmic evolution, the narrative that won Nobel Prizes and filled textbooks, might be fundamentally wrong. Webb was supposed to be our ultimate validator. It has become our ultimate challenger, showing us a universe that refuses to follow the rules we've spent decades establishing. 6 red dots appeared in Webb's deep field images like cosmic ghosts haunting the early universe. At first glance, these tiny specks seemed unremarkable among the thousands of galaxies scattered across the telescope's field of view. Then astronomers calculated their distances and ages, and the impossible became undeniable. According to every model of galaxy formation we've developed, these structures simply cannot exist at that time in cosmic history. It's like finding a skyscraper in a world where only mud huts should be possible. Each of these 6 galaxies blazes with the combined light of billions of stars. To put this in perspective, imagine trying to build a city in 1 year using only primitive tools and raw materials. The research team led by astronomers from Swinburne University published their findings in Nature and immediately sparked controversy throughout the scientific community. Think of galaxy formation like building a house. First, you need a foundation of dark matter to provide the basic structure. One of Webb's discovered galaxies weighs more than 100 billion times the mass of our Sun. To understand how staggering this number is, consider that our own Milky Way galaxy contains roughly 60 billion solar masses, and it has had over 13 billion years to accumulate this material. The Milky Way is like a massive oak tree that has grown slowly over centuries. These early galaxies are like finding fully grown redwoods in a garden that was planted last week. Mike Boylan Colchin from the University of Texas calculated the implications and reached a disturbing conclusion. The galaxies are so massive that they would require fundamental changes to our understanding. It's like discovering that a 3-year-old child weighs more than a full-grown adult. These galaxies exist when the universe was only 3% of its current age. Imagine compressing your entire adult life into just 1 year and accomplishing everything you've learned and created. The mass measurements come from analyzing the galaxy's light output and stellar populations. Brighter galaxies generally contain more stars, and more stars mean more mass. For these massive early galaxies to exist, they would need to convert nearly 100% of their available gas into stars. This efficiency rate represents the absolute theoretical maximum of what's physically possible. It's like demanding that a factory achieve perfect efficiency with zero waste. In today's universe, galaxies typically convert only about 10% of their gas into stars. Think of it like trying to build a campfire in a windstorm. Most of your fuel gets scattered before it can ignite. When massive stars die in supernova explosions, they blast enormous amounts of energy and material into space, disrupting nearby gas clouds and preventing new stars from forming nearby. Imagine trying to fill a bucket with water while someone is shooting holes in the bottom. In normal galaxies, stellar feedback creates these holes, allowing most of the gas to escape. These early galaxies would need buckets with no holes whatsoever, retaining and converting every single atom of available material. We're dealing with galaxies that would need to operate under fundamentally different physical laws. At the heart of these impossible early galaxies lurk supermassive black holes weighing billions of times more than our Sun. Webb has detected these cosmic monsters actively feeding and growing when the universe was less than 1 billion years old. There's a fundamental speed limit to this process called the Eddington limit. Think of it like trying to drink from a fire hose. There's only so much material a black hole can swallow before radiation starts pushing away additional food. These early universe black holes accomplish this growth in less than 1 billion years. It's like finding a fully grown elephant in a nursery where only mice should exist. Webb discovered one quasar containing a black hole that weighs 10 billion times more than our Sun, making it the most massive black hole known in the early universe. This creates a chicken and egg problem for cosmology. Did the black holes form first and then help create the galaxies around them? Or did the galaxies form first and then create the conditions for rapid black hole growth? In the deepest images Webb can capture, astronomers discovered 9 sources of brilliant blue ultraviolet light blazing from an epoch when stars shouldn't have existed yet. These mysterious objects shine when the universe was only 100 million years old. Picture trying to see individual candle flames from several miles away on the darkest night imaginable. That's the equivalent of what Webb achieved in detecting these ancient light sources. Pablo Pérez González from the Center for Astrobiology in Madrid led the team that discovered these impossible light sources. Some of these light sources appear point-like, suggesting they might be primordial black holes, theoretical objects that could have formed in the universe's first moments. Finding organized light sources at this epoch is like discovering a symphony orchestra performing in what should be an empty concert hall. We're seeing the universe when it was less than 1% of its current age. At this cosmic moment, the first atoms had barely formed, and the universe was still emerging from the opaque fog. Current models predict that forming massive galaxies should require at least 2 billion years. The structures Webb discovered accomplished this feat in less than 700 million years. It's like watching someone complete a marathon in the time it takes to run a sprint. Think of galaxy formation like cooking a complex meal that requires multiple steps in sequence. You can't skip preparation time, you can't rush the cooking process, and you can't combine certain steps without ruining the result. The 700 million year time frame becomes even more constraining when you consider the hostile conditions. Gas temperatures were much hotter, the universe was denser, creating more turbulent conditions. Cosmologist Catherine Nelson explained the fundamental problem. Our cosmological theory predicts that galaxies of this mass should take much longer to assemble. The timeline mismatch represents a factor of 3 difference between prediction and observation. The carefully constructed timeline of cosmic history, supported by decades of observations and theoretical work, begins to crumble under the weight of Webb's discoveries. The universe is expanding, but astronomers can't agree on how fast. This disagreement, known as the Hubble tension, represents one of the most significant crises in modern cosmology. Different measurement methods yield expansion rates that differ by enough to suggest something fundamental is wrong. Think of it like 2 different rulers that give you different measurements for the same object. One ruler consistently shows 10 inches, while the other shows 11 inches. The difference is too large to be measurement error. Adam Riess, who won the Nobel Prize for discovering that the universe's expansion is accelerating, led the latest Webb study that verified the higher expansion rate. Webb's observations have confirmed and reinforced the higher expansion rate values, ruling out the possibility that previous measurements were biased by instrumental errors. The tension might be resolved by introducing new components to the early universe, such as early dark energy, that gave cosmic expansion an unexpected boost shortly after the Big Bang. The expansion rate problem might be connected to the massive early galaxies Webb discovered, both pointing toward missing physics in our cosmic models. The early universe should have been chaotic and turbulent. Webb's observations reveal instead a cosmos that was surprisingly organized with galaxies showing clear patterns and arrangements that suggest sophisticated cosmic organization. Many distant galaxies have flattened oval disk shapes and elongated structures rather than irregular chaotic blobs. It's like discovering that a construction site has organized itself into neat rows of completed houses. Think of galaxy formation like choreographing a complex dance. In the early universe, dancers should still be stumbling around, learning basic steps. Instead, Webb discovered cosmic dancers performing intricate routines with precision. Simon Lilly from ETH Zurich discovered that early galaxies had already created vast bubbles of ionized gas extending 2 million light-years around themselves. These bubbles represent large-scale organization requiring coordinated star formation across enormous cosmic distances. The young stars pumped out ultraviolet radiation that cleared surrounding gas, creating transparent regions in an opaque early universe. Coordinating this process across millions of light-years requires cosmic organization that conflicts with our understanding of the early universe as chaotic. It's like discovering that a newborn baby has learned to solve complex mathematical problems. In the early universe, gas temperatures were scorching hot, creating conditions that should have prevented galaxy formation entirely. The cosmic gas needs to cool down significantly before gravity can overcome thermal pressure and collapse matter into stellar nurseries. Imagine trying to build a snowman during a heat wave when temperatures are over 100 degrees Fahrenheit. The snow melts faster than you can pack it together, making construction impossible. Alison Kirkpatrick from the University of Kansas explains that galaxies cannot form quickly because the gas in the early universe is very hot, preventing it from collapsing. Hot gas has high thermal pressure that resists gravitational collapse. The faster gas molecules move due to high temperatures, the more they resist being compressed into dense clouds necessary for star formation. This creates a fundamental barrier to early structure formation that should have delayed galaxy development by billions of years. The thermal energy creates outward pressure that counteracts the inward pull of gravity. The combination of high temperatures, high pressures, and hostile conditions in the early universe creates a perfect storm of obstacles to galaxy formation. Webb's discovery of massive organized galaxies thriving under these impossible conditions suggests our understanding of cosmic physics may be fundamentally incomplete.